Hey there. So my name is Mikkel. I represent Moving Boundaries team. Right here, I have my little magnetic compass. Where does my compass point? Oh, come on. It points to the north magnetic dipole, right? Because the Earth is essentially a big old bar magnet. But if I were to stand here, say, in 10 years from now, and I follow my compass around, would I still end up in the same location? No, exactly. I would not. Because the North Magnetic Dipole, as you can see on the left here, is moving, and it's moving fast. In the past 30 years or so, it's moved more than 1,500 kilometers from northern Canada and eastwards. And the reason for this is due to movement and flow of metal alloys in the Earth's interior. And another change that we see because of this is actually a reduction in the strength of the magnetic field, the magnetic dipole moment, if you want to use a fancy scientific word for it. And that's very interesting because the magnetic field protects us from space weather effects like solar flares, solar storms, so on and so forth. And of course, the most well-known visible manifestation of these space weather effects is the aurora, the northern lights, right? So on the top right there, you can see kind of the auroral oval, which is the region where you're most likely to be able to observe auroras. So kind of a relevant question for Svalbard that our team wanted to answer is that given these changing and shifting magnetic pole, how does that affect the location of the auroral oval? So the way we investigated this is by looking into about 30 years worth of data from both local sources in the form of the IceCut Svalbard radar just up by Mine 7 up on the mountain there, as well as global sources in the form of polar orbiting satellites. And what we found is that the auroral oval does in fact move slowly towards the east, which corresponds with the movement of the pole, as you can see in the figure there. Now, does this mean that soon we're not going to be able to see any northern lights anymore, and all the tourists are going to be disappointed? Not so much, because the more short-term space weather effects due to the sun are still much larger than this very small shift that we see due to the moving pole. So that means that the sun is very much still the boss over the magnetic field. Still, the magnetic field is very important and very relevant to us, because with the changing magnetic field, we, for example, constantly have to update maps, update the declination. Moreover, airplanes, they use magnetic headings, magnetic bearings when they land at airports. So all runways are designated with a number that sort of gives the magnetic heading that they have to follow in order to land safely on an airport. And these have to be constantly updating. So for example, as you see in the figure here, they're changing the runway designators on the airport here in Longyearbyen because it's changed by 10 degrees, and this happened in 2023. Another change that's very important is that because of the weakening magnetic field, in the future, most likely we're going to see a reduction or an increase of space weather effects here on Earth.